Hi everyone, Assalamualaikum. In this section, we are going to take a look at integrals of rational expression of polynomials. Okay, we know that the rational function is a ratio of two polynomials. Okay, now we look at example 1. Evaluate integration of 2x squared plus 7x plus 3 over x plus 1, x minus 1, x plus 2 dx. Okay. From here, the integrand is a proper rational function because the degree of numerator less than the degree of denominator. Okay. Therefore, by using the form of partial fraction, we can write 2x squared plus 7x plus 3 over x plus 1, x minus 1, x plus 2 into the sum of partial fraction. Okay. And from here, we have denominator with degree 3 and numerator with degree 2. Okay, and this is proper fraction because the degree of the top is less than the degree of the bottom. Alright? And when we write into the sum of partial fraction, we need to consider the denominator. Okay, from here, the denominator is a distinct linear factor. Alright, so we can write into 3 partial fraction, okay, because from the given denominator we have 3 linear factor. Alright, and then from the first fraction we have denominator x plus 1, okay, and this is linear factor, so we can write numerator equals to constant a. Okay, and from the second fraction, we have denominator x minus 1, which is also linear function. So we can write constant b in numerator. Okay, and from the third fraction, we have denominator x plus 2, which is also linear function. Okay, so we can write numerator equals to constant c. Okay, and after that, we can check. Okay, we have constant a, b, and c. There are 3 constants here. Okay, because from the given denominator, okay, it is degree 3. Okay, so that's why we have 3 constants a, b, and c. Okay, and after that, we can naming it as equation 1. Okay, and then we standardize the denominator. Okay, so from the given question, okay, we can write denominator of right hand side equivalent to denominator to left hand side. Okay, and then for numerator for right hand side, okay, we can multiply a times x minus 1 times x plus 2. Then we can put here. Okay, and then plus b times x plus 1 times x plus 2. So we can write here. Okay, and then plus c times x plus 1 times x minus 2. Then we can put here. Okay, and then since the denominator of both sides are equal, okay, so we can say that the numerator for both sides also equals. Okay, so we can write 2x squared plus 7x plus 3 equals to a x minus 1 x plus 2 plus b x plus 1 x plus 2 plus c x plus 1 x minus 1. Alright, then we can naming it as equation 2. Alright. Alright, from equation 2, we need to find constants a, b, and c. Okay, there are 3 constants here. Okay, so we can use substitution method. Okay, we substitute the value of x into equation 2 here. Okay, since we want to find three values of constants a, b, c, so we need to substitute three values of x. Okay? For easy calculation, we can equate the first factor in denominator equals to 0. Then we find the value of x. Okay? So from here, we equate the first factor x plus 1 equals to 0. Then we get x equals to negative 1. Okay? Then, when x equals to negative 1, we substitute into equation 2 here. Okay? So, from equation 2, we have 2 and then we replace x by negative 1 and then squared plus 7 times we replace x by negative 1 plus 3 equals to a, we replace x by negative 1 minus 1 and then we replace x by negative 1 plus 2 and then plus, when we substitute x equals to negative 1 into here, we get 0 here. Okay, because we set x plus 1 equals to 0. Okay, so all term containing factor x plus 1 will equals to 0. Alright. Okay, and then we simplify. So we have 2 minus 7 plus 3 equals to a times negative 2 times 1. Okay, so we get negative 2 equals to negative 2a and a equals to 1. Alright. Alright, to find constant b, we can equate the second denominator equals to 0. So we find the value of x. Okay, we equate the second denominator, which is x minus 1, to 0. Then we get x equals to 1. Okay, then when x equals to 1, okay, then we substitute into equation 2 here. Okay, so we substitute 1 into variable x in equation 2. So we get 2 times 1 squared plus 7 times 1 plus 3. And then when we substitute 1 into x here, we get 1 minus 1, which is 0. So we get 0 here. Okay, because 0 multiplied by any values will equals to 0. Okay, and then plus b and then 1 times 1 plus 1 and then 1 plus 2 and then plus, when we substitute 1 into here, okay, we get 1 minus 1, which is 0. So 0 multiplied by any value will equals to 0. Okay, because we said earlier x minus 1 equals to 0. So all term containing factor x minus 1 will equals to 0. Alright. Then we simplify. So we have 2 plus 7 plus 3 equals to b times 2 times 3. Alright. Then we simplify. So we get 12 equals to 6b and b equals to 2. Right? Alright, from the previous slide, when x equals to negative 1, we get a equals to 1. And when x equals to 1, we get b equals to 2 after we substitute into equation 2. Okay, so now we want to find the third constant, which is c. Okay, to find the third constant, we need to equate the third factor in denominator to 0. Okay, so we equate x plus 2 equals to 0, we get x equals to negative 2. Then we substitute x equals to negative 2 into equation 2 here. Okay, so we get this. Okay, the term containing factor x plus 2 will equals to 0. Okay, then we can find the value of c. Okay, so after we simplify, we get c equals to negative 1. Alright. After we find the values of a, b, and c, okay, we substitute the values of a, b, and c into equation 1. Okay, we recall back equation 1. Okay, this is equation 1. Okay, from the previous slide. Alright. So now we replace a equals to 1. Okay. We replace b equals to 2. And we replace c equals to negative 1. Alright. Then after that, we simplify, so we get 1 over x plus 1 plus 2 over x minus 1, and then plus and minus here, so we can write minus 1 over x plus 2. Okay, so now we done express this rational function into the sum of partial fraction. Alright. From the previous slide, we done express this proper rational function into the sum of partial fraction. Alright. So now we can integrate this function. Okay. So therefore, integration of 2x squared plus 7x plus 3 over x plus 1, x minus 1, x plus 2 dx equals to, okay, we just integrate one by one here. Okay, so we can integrate 1 over x plus 1 dx plus, we move constant 2 outside integration sign. So we get plus 2 integration of 1 over x minus 1 dx, and then minus integration of 1 over x plus 2 dx. Alright. And then from here, okay, to evaluate integration of 1 over x plus 1 dx, 1 over x minus 1 dx, and 1 over x plus 2 dx, okay, we can use either method 1, if the numerator is the derivative of the denominator, so the answer is ln denominator. Or we can use this formula. Okay, when we move the denominator to numerator, we will get bracket to the power of negative 1. Okay, so we can use this formula. Okay, 1 over a here, a means the coefficient of x here. Alright, or we can use u substitution. Okay, where u equals to x plus 1 to evaluate this function, u equals to x minus 2 to evaluate this function, and u equals to x plus 2 to evaluate this function. Okay, we can use either method 1, method 2, or method 3. Okay, let's say in this video we use quick method. Okay, method 1. Okay, when we use quick method, if the numerator, okay, this is numerator, is a derivative of denominator, okay, means that when we differentiate denominator, x plus 1, we get 1. When we differentiate x minus 1, we get 1. When we differentiate x plus 2, we get 1 here. So all the numerator is the derivative of denominator. So the answer is ln denominator. Okay, so we can write integration of 2x squared plus 7x plus 3 over x plus 1, x minus 1, x plus 2 dx equals to, so when we integrate this function, we get ln denominator, ln x plus 1, and then plus 2, and then when we integrate this function, we get ln denominator, ln x minus 1, okay, because numerator is a derivative of denominator, and then minus, when we integrate this function, we get ln denominator x plus 2 because the numerator is the derivative of denominator. Alright, so this is the final answer when we integrate this proper rational function. Alright. Alright, in general, when we integrate proper rational function in type 1, okay, we will get answer ln. Okay, because in type 1, we express into the sum of partial fraction which has numerator equals to constant and denominator equals to linear. Alright, so when denominator equals to linear factor and numerator equals to constant, we will get ln, okay, when we integrate. Okay. Coming up next, integration by partial fraction, type 2, denominator with irreducible quadratic factor. Okay. Thank you for watching. Stay tuned. Bye. Assalamualaikum.